Hello, let's do the New York Times Hard Sudoku for December 24th, 2024. Happy New Year's Eve, everyone, if you're watching this in the evening. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, starting here, we have all three fives already. The sixes, we have two of them, puts a six in one of these two cells. We also have two sevens here, puts a seven in one of these two cells. That's 5, 6, 7. We have 5, 7. We also need to do 2 and 9. So the 2, I'm looking at this 2 down here, and then this 2 looks in. And so that leaves just 2 places for 2 in this box. That's going to do what's called pointing. So if 2 is in the box, notice we're talking about the box, says 2 is in one of these two cells. They both happen to be in row 1. So no matter where the 2 ends up in this box, it will be in row 1, meaning we can't have another 2 in row 1. So that's what's called pointing, where within a box, the places a digit can go, point at the rest of the row or the rest of the column, in this case the row, and say that there can't be more 2s in the row. So these 2 can't be 2, that's important. And these can't be 2 because of this 2 here. You can see, if you can understand why these can't be 2 because of this 2, just imagine wherever the 2 ends up, it's going to do the same thing. So one of these 2s does that, whichever one ends up true. And so now there's a 2 in one of these 3 cells. All right, we also have the 9. So I think the 9 is similar. So this 9 looks in, this 9 looks up. But actually, because this 5 is handily placed, there's only one place for 9, so we can just place it. Now these two 9s look in, putting a 9 down here. Alrighty, I want to look at anything else that looks up through here. So we took care of the 9, the 9 and the 2, but we also have the 1 looking up here. And that since all 4 of these are filled now, that means the 1's in one of these two cells. Now I could say that points, but I can do something even more powerful, which is look at what these corner marks are telling us. That in one of these two cells, we have a 1, and in one of these two cells, we have the 2. Well, they're not going to be in the same cell, so one of these will be 1, and one of them will be 2, leaving no other digits. So we cannot put any other digits in these cells because they have to be a 1-2 pair. So because they're a 1-2 pair, that means that we can't put 1 in any of these cells. This one looks up. It's not good enough to mark anything, but we do get that pair. And that means that this is a triple for the remainder of the box. Because 1 and 2 are accounted for, we need 3, 4, and 8. Now that 3, 4, 8 triple takes 3, 4, and 8 out of the rest of this column. Because the 3, 4, and 8 are up here for the box, meaning we can't have 3, 4, 8 for the rest of the column. So these are going to be the 3 digits that remain that aren't accounted for, the 5, 6, 7. I'm going to mark that as well. This can't be 6 because the 6 is here. Now from that, what we can see is in this column, and I actually saw it from the triple itself, you can do that too, is that because this can't be 6, the 6 ends up in one of these two cells. Now this does what the opposite of claiming, the opposite of pointing, which is called claiming. It's the same concept, we just sort of switch column and box, right? So in this column, we're talking about the column here, we are going to place a 6 in the column, and it's going to be here or here. And both of those happen to be in box 9, meaning the 6 in column 8 will be in box 9 here. So we can't put any other 6s in the box. So none of these cells are 6. If we look at this box here, we can actually see this 6 looks down, this 6 looks in, putting a 6 in one of these two. And that does point down along with the 6, telling us the same thing. So there's more than one way to find the same conclusion. And when they agree, that's very nice. We also have this 4 looking in. That puts a 4 in one of these two. This is another hidden pair. That's a hidden 4-6 pair. Now what that does is, remember, it removed any other possible digits from those cells. So we want to think about the consequence of these no longer being able to be, for example, 2, 3, 5, 7. Actually, it already couldn't be 7. So 2, 3, 5 are the big ones that they can no longer be. This already couldn't have been 2, 3, but now this can't be. So this 5 looking down, and these can't be 5 anymore. Remember, I was paying attention specifically to the digits that were removed from these two, and that's what led me to believe that 5 would be important to look at. And so 5 is in one of these two cells, and that is actually going to point. That points in here. This 5 looks down, putting a 5 one of these two. It also points here, but there's no, I guess this 5 helps, but it's just one of these 3. I don't mark 3 in a corner like that. 3 that, if they're not all in a row like these, I don't mark it if it's 3. It just confuses me. All right. I also said something about 3s. Yeah, 2, 3, 5 were the big ones removed. What are all the digits that go here? So other than 4, 6, we need 2, 3, 5, 7, 8. Right. So The 8 looking up here, this can't be 8 because of 3, 4, 8 triple. So, and this 8 looks in. So 8's in one of these two cells. Okay. Let's continue looking at this band. I'm pretty sure this top band. Actually, I do want to go back to this top band for a second because whenever a row, column, or box is down to 4 or fewer digits, I like to at least think about what are those digits. If it's 4 or fewer, I think about it. If it's 3 or fewer, it's always going to be something I'm willing to mark because I'm willing to mark when there's 3 left in a cell. But we need 1, 3, 4, 8. So this can be any of 1, 3, 4, 8, unfortunately, but this sees 3, 8, and this sees 4. So if I put 1, 3, 4, 8 here, this can't be 4, this can't be 3, 8, and we want to look to see if those do anything, but not at the moment. So it's just a good opportunity to find restrictions in the row is when it's already highly restricted because most of the digits are placed. Makes sense, right? There are also 4 remaining here because we know where the 4, 6 pair is. So we need 1, 2, 3, and 5. This can't be 1, so this is 2, 3, 5. And these can't be 2, so these are 1, 3, 5. The top one can't be 1. Okay, now I am going to do this band here. So let's start with the 1, 9. So this one looks in, this one looks in, putting a 1 in one of these two cells. Nothing over there for 1s. We have the 9. These 9s look into this box, putting a 9 in one of these two. These corner marks like this, where they don't line up in a row or column, they don't point or claim or anything, but they are still useful because when one of these gets eliminated, we can immediately place the other one. And that's always very nice to be able to do, to more quickly solve the puzzle, not have to rescan what we already found. The 3 doesn't do much. The 4, not enough. We have the 4, 6 pair here. Okay, and we have 2, 6, and 8. So the 2, the 6, we already got the 6 there. And then the 8, not really doing much. Okay, we already have it here. I notice we have 1, 2, 3, 4, 6, 8, 9. No repeats in this band. So one thing to watch out for is if there's any cells that see most of these digits. So I feel like there's not much opportunity for that, unfortunately, but we also have these 5s pointing in. So maybe these. Honestly, I don't think there's much. I was looking for restricted cells, but I don't really think there's much to go on there. We'll do that later if we need to. Let's move on to the next band. So we'll start with the 4s. This 4 looks down, putting a 4 in one of these two. We also have the 7. So we have these 7s. Doesn't really help me. Okay, 4 and 7. We've got the 1. Unfortunately, not good enough. We have the 8s. The 8 is placed in this box. That's nice. These two 8s look up, placing this 8. So that can't be 8 anymore. The 8 ends up in one of these two cells in this box. That points down. This 8 looks up, this 8 looks in, putting an 8 in one of these two. So 8s, we've got these 8s, we've got these 8s. Those aren't going to resolve themselves. All right, nice for 8s. We also have the 2. Not quite. Oh, actually, no, it's there. Yeah, we have the 2 in one of these two. And then we have the 8. We did the 8s. We did the 4. Okay. So that's it for our band scanning. We didn't get a whole lot out of it, so I must have missed something. This box is down to 4 digits after we place that 8. Let's take a look. We need a 1, 3, 4, 7. I mean, this can't be 7, so it's 1, 3, 4. Okay. 1, 3, 4, 7. This can't be 7 either, so it's 1, 3, 4. These are any of them. This column is down to 3 digits, actually. We need a 1, 3, and 5. So this one and this one, see here. So the 1 can only be in one place. That's huge. So this column needs a 1. We're not worried about this box, right? I get this question sometimes, which is why I'm explaining it. This 1 looks in here. 1 could be in a lot of places in the box, but look at the column. The column needs a 1. It could only be right there. So we have to place the 1 there for the column, which does also end up being the 1 for the box. And now we can place a few more 1s. These 2 1s now look up. Putting a 1 somewhere up here. This is now a 3, 5 pair. Does this do anything else? Not that I'm seeing. Oh, this 1-2 pair, don't forget about that. This can't actually be the 1 because of the 1-2 pair. I'm noticing this cell here, it only has a 6 corner mark in it. And we have the 1, 2, 8, and 9 also corner marked. So this cell is not 1, 2, 8, 9, and it's also not 5, 7, and it's also not 3. So it's going to be quite limited. Probably just 4, 6, but anyway. We can't be 1 because of the 1-2 pair. We can't be 2 because of the 1-2 pair. Can't be 3. Could be 4. Can't be 5. Could be 6. Can't be 7. Can't be 8. Can't be 9. So it is down to 4, 6 only, as I said. This can't be a 4, but it could be a 3, unfortunately. This is what? Is this 3, 6, 8 only, though? 1, 2, could be 3, can't be 4, 5, could be 6, can't be 7, could be 8, can't be 9. Yeah, it's down to 3, 6, 8. We could have a triple in this column. We need a 3, 6 somewhere only. Not seeing that. All right, what else can we do? I'm going to do a vertical scan, make sure I didn't miss any vertical buddies. I'm not as careful with the vertical scan because we already basically looked for everything in the horizontal scans. But it does give me another chance to look at everything. So we got the 4, 7, and 8. They're taken care of. We've got the 1, 2. Took care of that. The 6s. Okay, we haven't taken care of these 6s. Just puts a 6 somewhere down here. Not super exciting. And then the 8s are taken care of. Okay. Over here, we've got the 1 and the 8. The 1s are taken care of. The 8s are as well. Got the 3 and the 4. Not much to do with those. Okay. Then over here, we've got the 2, 4, and 8. And the 1, 9. Okay, what I didn't get is these 2 9s looking down. So there's a 9 in one of these two. Huh. Do you remember the 6 claims this box? Okay, yeah, we had this 4, 6 pair, so kind of baked in. Okay, so what am I missing in this? I don't have a lot marked even. This row is down to 5 digits, but it looks suspicious for some reason. I don't know why. Maybe it's not. We need 4, 5, 6, 7, 8. These can't be 6, 8. So 4, 5, not 6, 7, not 8. And this can't even be 5. Okay. This can't be 5, 7, or 4. So it's not 4, 5, could be 6, not 7, could be 8. This can't be 4 or 6. So it could be 5. It can't be 5 either. So it's 7, 8 only. Interesting. So they're all pretty limited, but they don't do anything directly. Wait, the 5. The 5 can only go here in the row. This 5C's here, this 5C's here, this 5C's here. And the hidden 4, 6 pair removed 5 from this cell. Very interesting. So that's our 5, that's our 3. I think that's gonna help a lot. That's our 3. Yeah, we finished this column. So let's see what we can do with these digits. We do have 2 3s here now, and these can't be 3. We have the 3, 4, 8 triple and the 3 looking up. So I missed pencil marking 3s, actually. But anyway, now this is the 3, and that makes this the 8, giving us the 6 and the 8 here. We get our 4 and 6 here. That's our 7. 2, 5, 7, not 5, so only 2, 7. Okay, I got a ton of digits. This 7 looks up. Placing this 7. This is 1, 3, 4. This is a pair. A 4, 9 pair. This 4 tells us this is 9, this is 4. Places the 4 in this box. 4 gives us the 3. Nice. I think we collapsed it. That was what we needed to find, this 5. That's tricky. 2, 5, 7 here. This is a triple. We know we need a 1 in the row, and look how we have the 1's corner marked this way. So this is definitely going to be the 1. That's our 4, that's our 6, that's our 8 and 4. We get our 3 and our 8, 1 and 3. That's our 4. This is a 2, 9 pair. I'm not even going to bother marking it because it's going to resolve soon. Whole puzzle's resolving soon, is why I know that. 2, 9 pair here. I'll mark that. And then this triple, we need a 1, 3, and 6. And this cannot be the 1 or the 3. So that gives us the 6. That 6 looks over, giving us the 7, giving us the 5, 2, and 7. We get our 7 here, the 1 and the 2 here. That's a 6, that's a 5. What's this pair? 1 and 9? Not resolved. Okay. This is 2, 9. It actually does make a 2, 9 pair here, but we may not need to use that. Let's see. We need a 1, 3, 6, 9. 1, 3, 6, 9. This can't be 1, 3, or 6. So this is a naked 9. Giving us the 1, the 2, the 9, the 3, the 1, the 2, the 9. The 2 gives us the 9 and the 2. This row finishes with a 6. And then this box, we need a 3, which goes here. We need a 5. Don't know where that goes. And we need a 7. Okay, so this 7 says that's 5, 7. We need 2, 5, 9 here. So this is our 2. This is our 5. This is our 9. And we're done. Wow, okay. So the whole puzzle kind of hinged on just finding this hidden 4, 6 pair, which then gives us the 5 in this row. I feel like that those were kind of the 2 key steps that might have been difficult to spot. But cool. I enjoyed that. I hope you did too. Let me know how you did. And if you did enjoy this, why not leave a like, subscribe, and a kind comment below.